Can you imagine a world where humans didn't have memories? Well, we know that memory is an important aspect of our lives. Unlike humans that can remember the food we ate last night or the shoes we bought last week, computers can only remember two states: 0 or 1, yes or no, on or off, etc. There are different ways in making a computer remember ones or zeros using hard drives, flashes, tapes, floppy disks, etc. We'll be looking at the memory in the CPU, such as registers, program counters, etc. So we'll be using circuitviz to simulate this memory. Alright, I'll just go ahead and launch the simulator. Okay, so this type of memory used in program counters and registers are made up of flip-flops. They are used to store two states, which, so let me just draw that out here. Start here. So they're able to store two states, usually zeros and one. So they use a positive feedback where the output is connected to the input. As you can see, I'm using a NAND gate. There are other ways of building flip-flops using different types of gate, but NAND gates are preferred because they are less expensive, they are cheaper, they're cheaper, less expensive, they are easier to design, and they use fewer resources slash transistors. Okay, so let's go ahead and build a circuit. We connect the input to one NAND gate input and second to another NAND gate. Draw this. Stick it in the gates. Okay, so yes, and one of the reasons why this is used is flip-flops is because they are able to store these two states indefinitely, and they don't change their output till triggered by an external input, and of course while voltage is applied, so they don't change their outputs till they actually triggered by an external input. So that is one of the reasons why they are used. Memory, right? Okay, so I'm going to connect outputs here. Let me just extend this. Okay, so yeah, so we need to be able to set and reset the a memory. We need to be able to say, okay, no, we change them. I want to store 0 or want to store 1 now, right? So when we reset this, let's name this set, and let's name this reset. Right. So when we set our input, say 1 and 0, this place we set it to a 0, and when it's 1 1, voila, memory is able to store the previous state. You can also go ahead and reset this. So we're setting this back to 1, and we'll do this for 1 again. We're still able to store a previous state. So that's how we're able to build a memory with so this is how we're able to build a memory.